Hello everybody, welcome to sketching the hyperbola. So, in grade 10, when you sketch the hyperbola, we had something as follows. Our hyperbola equation looked something like y is equal to a over x plus q. And what did these indicate to us? The a actually indicated us when a was greater than 0, then what we would be working with is essentially the part where in a Cartesian plane, where there's existence of the function is going to be in the first and the third quadrant. Okay. So when a is greater than 0, it would be the first and the third quadrant. But when a is less than 0, then what we are saying is there's going to be existence of the function in the second quadrant as well as the fourth quadrant. Okay, so if a was positive, then it would look like this. If a was negative, it would look like that. Okay, and then our q value is essentially just our asymptote. But which asymptote? Our vertical asymptote. Am I making a mistake here? Is it a vertical? No. Why? Because it's horizontal. The reason why it's horizontal is because the equation of the asymptote is in the form of y is equal to q. Right? And we know that on a function, when we have y is equal to something, it would be at a point at y, and it will be horizontal. And that is the asymptote. And we suppose that this value is q, such that y is equal to q. Okay, so that's something to kind of like catch you out there. This is the asymptote, where the function can never intersect with. But what happens if we take it to grade 11 level? What is the only change that we're going to have? So this was grade 10. But what about grade 11? Grade 11 is now when it's y is equal to a divided by x minus p plus q. Can you see the only change is the minus p? And what does the minus p indicate? The minus p is going to be the vertical asymptote. This is the only change that we have for this year. And how do we find out where that asymptote lies? Essentially, we're going to take the x minus p. Okay, we're going to say x minus p is equal to 0. And this implies to us we take the negative p over, we have x equals p. And this would be our asymptote. This is our x asymptote, which is horizontal. Asymptote equation. It's in the form of x equals p. Okay. SE. So this is just some general understanding about what to expect. And then when we get into the question that we're about to do, the example that we're doing for this video, you'll actually see how it's used. So let's get into the example. Alright, so we are told to sketch f of x equals 4 over x minus 2 plus 4. So there's a couple of steps to this. The first step is to understand in which quadrants are we dealing with. The second one is now for us to find out the asymptotes. Then afterwards we're going to find out the intercepts, then the axis of symmetry, then the points of intersection, then we can sketch. Sounds like a lot. It is a lot, but we can push through this. First things first, we need to find out where does it lie. What is the shape of this graph? And we can clearly see that the a value here is greater than 0. Right? So since the a value is greater than 0, this indicates that we are going to be working with a shape such as this, where we have the first quadrant and the second quadrant. The third quadrant, sorry. Okay, so it looks something like that. But it won't look exactly like this. I'm just giving you that idea. Now that we got the shape first quadrant and third quadrant, we need to know the asymptotes. What are the equations of the asymptotes? Now remember, I told you how to find the equation of the asymptote for the vertical ones. So x minus 2 is equal to 0. I said let this denominator be equal to 0 such that when we solve for x is equal to positive 2. And this is the equation of the horizontal asymptote. Okay. And then for the y, we know that this is just the q value. This is the vertical. No man, this is the damn this is the vertical, man. What is wrong with me? This is the vertical. Okay. Vertical. Okay. And then this other one, I'm not even thinking straight here, which is y is equal to the equation of the horizontal one. The horizontal asymptote is in the form of y equals, and it's y equals to q, which is 4. And this is the horizontal. How on earth am I messing this up all the time? Horizontal SE. Okay. There we go, finally. Holy crap. So now we got our asymptotes. We're not going to draw that yet. But the next thing we're going to find is our x-intercepts. Now how do we find our x-intercepts? For the x-intercept, we need to let y be equal to 0. Okay. Meaning that we need to do the following. We are going to say that 0 is equal to 4 over x minus 2 plus 4. Where we take the 4 over as negative 4 is equal to 4 over x minus 2. But because this is an equation, we can rewrite negative 4 as negative 4 over 1, so that we can cross multiply, right? We multiply across, we'll have 4 times 1, which is just equal to 4. And then if we multiply across here, negative 4 times x minus 2, that would be negative 4 into x minus 2. Okay. And then from here, what do? We just multiply the negative 4 in. So we're going to have negative 4x plus 8, which is equal to 4. And if we just take this positive 8 over, we're going to have negative 4x equals to 4 minus 8, which is just equal to minus 4. And therefore, that implies to us that our x-intercept, if we divide both sides by 4, negative 4, it's just going to be 1. Okay. So that is our x-intercept. Our y-intercept, fairly easier, is when we let x be equal to 0, which implies to us that we're going to have f of 0 equals to 4 over 0 minus 2 plus 4. Okay, and we know that this is just y at x equals 0, so therefore we just simplify, right? 4 over negative 2, which is equal to negative 2, plus 4, and therefore y is equal to 2. Okay, so obviously in this case our x-intercept is going to be 1 and 0, and our y-intercept is just going to be 0 and 2. So we found our x and y-intercepts. The next thing we just need to find is the axis of symmetry. And how do we find the axis of symmetry? This is how we find the axis of symmetry. Okay, so axes of symmetry are linear functions, right? They're linear, meaning they're in the form of y equals mx plus c. So if we want to find the one with the positive gradient, the one with the positive gradient is essentially when we say y is equal to positive x minus p plus q. And then the negative one is essentially where we're just saying y is equal to the negative version of this plus q. Okay. This is just how you must remember it in this case, and obviously we need to write it in the form of a linear equation. And clearly it's x to the power of 1 minus a constant plus a constant. No, it's not the parabola because there's no square. So yeah, that's essentially the equations that we use. Okay, but what is our p value? We know that p is essentially just the vertical asymptote, which is 2. Okay, and the horizontal asymptote is just 4. So therefore, we can say it's y is equal to x minus 2 plus 4. And then y is just equal to x, and then this is the plus 2. And then over here, y is equal to negative can go into this. So let's first actually substitute x minus 2 plus q. And then y is equal to, we take the negative in, it will be minus x plus 2 plus, what is our q value? I forgot to write it down. It's 4. So it's 4 over here. And then y is just going to be equal to minus x plus 6. So these are just two linear functions. Okay, it'll be the same with every single type of hyperbola. This is just the way that you do it. And then the next thing and the last thing that you'll try and find before you start drawing your function is going to be the points of intersection. So this is how we find the points of intersection. So if you didn't know how to do this, I don't blame you. So what did we say the a value was? We know that the a value is greater than 0, meaning we're working in what? Quadrant number 1 and quadrant number 3. But my question is, for every single coordinate in each quadrant, if we look at the coordinates in quadrant 1, both of them are positive, right? If we look at the coordinates in quadrant 2, then x is negative and the y is positive. If we look at the coordinates in the quadrant 3, x is negative and also y is positive. And if we look at quadrant 4, we notice that x is going to be positive and y is going to be negative. So therefore, using this understanding, we are going to choose our points of intersection to be a part of quadrant 1 and quadrant 3. Okay, meaning our coordinates should be both positive, and this one should be both negative when we're using the general form though. Okay, because sometimes the hyperbola can shift horizontally away from one of the quadrants. Like the hyperbola can shift from here and it can shift to the left side, and it'll probably be like somewhere here, and the point could be like within the 4th quadrant. So that is why we can't assume the coordinates. So we use a general form in order to find these points. So the points of intersection. Intersection. Okay, to find the points of intersection, we are going to use the form where we have what? Quadrant 1, which is both positive. But this is how it's going to look. It's going to be positive of the square root of a plus p. And then the other coordinate, which I'm going to try and separate properly, it's also going to be positive. And it's going to be positive square root a plus p. Okay. And then our other one, so this is for quadrant 1. Okay. The other one is going to be for quadrant 3. And both of the coordinates are supposed to generally be negative. So it'll be negative root a plus p. Okay. And then we'll have negative root a plus p. The question is, okay, well, let me write this down quickly. This would be quadrant 3. The question is, right, because both of these are positive and both of these are negative, what if it was a case where a was less than 0? right? Because I just indicated here, if a was less than 0, then obviously this sign would, if we were looking at the quadrant 2, then this sign would be negative and this sign would stay positive. And if we're looking at the fourth quadrant, let's look at this one, this sign would be positive and this sign would be negative according to the order that you see here. So that's just something that I would want you to recognize when you're trying the other questions by yourself. Okay. I just wanted you to intuitively understand that one. Point of intersection, all we're going to do is just substitute what we know. So this implies to us that our coordinate is just going to be positive square root of a, which is 4, plus p, which is 2. And then we're going to have the square root of 2 plus 2. Okay, why did I say 2? It's going to be 4. Also, one thing that I want you to understand here, right? This is an x coordinate, so we'll work with p and a. But here's one thing that I want you to be aware of. This one is a y coordinate, and why is p involved? P is not supposed to be involved within the y coordinates. So which means if you used it like this, it would be incorrect. So this is supposed to be q. So if some of you knew about it, right, which I'm happy for you, this would have to be q because it's involved within the y. And in this one, the same thing happens here. This is an x coordinate, and then here, this is a y coordinate. So which means this must not be p, this must be q. I hope you understand that, by the way. So I'm sorry for giving you a fright, because I like doing that. So which means our q value we know is going to be 4. So this would be 4. Okay, hopefully you caught that one. And then negative square root of a, which is just 4, plus p, which is 2. And then negative square root of a, which is, square root of a, which is just 4, plus q, which is 4. Okay. Then from here, we just simplify. Square root of 2 is just 2, 2 plus 2 is just 4. Okay, so I'm just going to actually write it a line below. So now we are going to have 4, and square root of 2 plus 4, which is equal to, square root of 4 plus 4 is equal to 6, okay? And what we are going to have here is we are going to have negative times the square root of 4, which is 2, and negative 2 plus 2 is equal to 0. Negative square root of 4 is just going to be equal to negative 2 plus 4, which is equal to 2. There's our points of intersection. This is essentially where the the axis of symmetry are going to intersect. And it's most likely going to be the positive one. But we'll see, okay? The reason why I'm saying it's going to be the positive gradient one is because our a value is greater than 0. So let's try this. Let's actually draw it. So we're going to draw our axes like so. And then what we're going to have is the y-axis and the x-axis. Okay. And then from here, we need to write down all the points that we know. Okay. What are the points that we know from what we worked out? So we first need to do our asymptotes. We have x equals 2 and y equals 4. Those are both lines. X equals 2, let's situate it here. Let's make our asymptotes red. So x equals 2 would be somewhere here. And then y equals 4, let's put somewhere here. Okay, such that when we do our line, I'm going to quickly just make it dotted, such that what we have is something like this, and it must be straight. Like that. And then we're going to have something like this. Okay. And there we go. I'm going to go back to normal, and then we're going to have this. And you need to label these, right? This is going to be y is equal to 4, and this is going to be x is equal to 2. Okay, so those are our asymptotes. Okay, what's next? Our intercepts. We know that our x-intercept is just 1 and 0, and our y-intercept is 0 and 2. So 1 and 0 would go somewhere before here. So it'll be between 0 and 2 here. So let's put it here. And let's draw it in blue. Okay. And then 0 and 2 would be somewhere here. Alright. So then from there, we just need to draw our shape. Does it make sense now? Our shape would look something like this. It goes towards the asymptote, but never touches that asymptote. Same over here in this direction. Okay, don't mind the little bit of a wobble over there. And then obviously we just connect the last part, which I can't see from here. There we go. Okay. And then the other one is on the first quadrant. Sorry. On the first quadrant. I apologize about that. And then it will look something like this. It represents the first quadrant. So it will look something like this, if you know what I'm saying here. And then the f is what the name of the function is. So we know that the coordinate here is going to be what? 1 and 0. And then this coordinate here will be 0 and 2. Okay, what other points do we have? We have axes of symmetry, right? So let's actually draw axes of symmetry. How do we do this? What is the equations of our axes of symmetry? It's y equals x plus 2. What does y equals x plus 2 look like? So I'm going to do it in a dashed way, but then the axis of symmetry can be represented by green. Okay, sorry. So the axis of symmetry is going to be y equals x plus 2, meaning that our 2 is our our y-intercept, and it's just a normal gradient. So it's going to look something like this. And I forgot to do the line. Okay, here we go. So it looks something like this. Okay. So this would be the one with the positive gradient. So it'll look something like this. Y is equal to x plus 2. And then our negative axis of symmetry, which is negative x plus 6, is going to just look something like this. It's just going to be perpendicular to our other line, which was this. It's going to be perpendicular to this one, so we don't have to worry about the scaling of that. So dashed, and then we're going to have something like this. Okay, so it looks something like that. Alright, and then the equation of this one is y is equal to negative x plus 6. Okay, and obviously that would indicate that there's a y-intercept of 6. But anyway, besides that, we need to write down our points of intersection, which clearly our point of intersection is in the first and third quadrant of our representation for our hyperbola. Not exactly, because you can see, right? This point, these points are both only positive, meaning both of them are in the first quadrant. Did you catch that? Clearly this one is going to be 4 and 6 because it's very far in the x-axis, and it's very like sorry, it's very, yeah, it's much further because 4 is greater than 0. And obviously here 0 and 2 is our y-intercept though. That's interesting. So this is also our point of intersection. So there we go. That is how we draw the hyperbola. So I apologize about the random coughs and whatever the heck happened earlier, honestly. But I was also trying to like catch some of you guys out because there's some intuitivity that you need to know, even if that's even a word. But otherwise, yes, this is how you draw or sketch the functions of hyperbolas.